Hello there, Mr. Sutton here with the Pre-Cal Honors 3-1 Extra Practice Number 1 Solutions on simplifying rational expressions. To simplify this expression, let's begin by factoring as much as we can. So we can start by taking out some common factors. In the numerator, between 18x squared and 2x cubed, I can definitely take out an x squared, and I can also take out a 2. So a 2x squared will come out of there, leaving me with 9 minus x. And down below, it looks like I can take out an x from all of these and also a 2. So taking out 2x, we have x squared minus 14 plus 45. Now, in the numerator, I'm actually going to do a little bit extra here. 9 minus x looks like it's fully factored, but you're not going to be able to cancel out 9 minus x with an x minus 9 if you get one of those down here. So what I'm going to do, it's a little bit sneaky, I'm going to factor a negative 1 out of this parentheses. That'll leave me with negative 9 plus x, which I can also write as x plus 9. So I can write the numerator then as negative 2x squared x minus 9. And that'll give me something that's a little bit more compatible with whatever I might find downstairs. Now down here, we still have that 2x that we took out, and I need factors of 45 that add up to negative 14. Well, there's 1 and 45, 3 and 15, 5 and 9. 5 and 9 adds up to 14 if they're both negative. So I can write x minus 5, x minus 9. And I'm really glad I took out that negative 1 to get me that x minus 9 now. But we'll get there in a sec. So first off, these 2's cancel completely. The x's can also interact as well. If I cancel those together, I'm left with an x in the numerator still. And these x minus 9's, as we foreshadowed, are going to cancel completely. So now left over in the numerator, we just have a negative x. And in the denominator, all that's left is this x minus 5. For this problem, let's go ahead and factor this to see if there's any common factors we can cancel out. So for the numerator now, I need factors of 49 that add up to 14. Not a whole lot to choose from. We've got 1 in 49 and 7 times 7. Well, 7 plus 7 equals 14. So I can break that up into x plus 7 times another x plus 7. Or I could write x plus 7 squared if I wanted, but you'll see why I write this twice. So down here now, we can factor out an 8. That leaves me with an x plus 7. And now one of these x plus 7's can cancel. And that's why I wrote the x plus 7 twice. If I wrote x plus 7 squared, then it would be too tempting to accidentally cancel out all the x plus 7's, when in reality there is one of them left over. So in the numerator, we have that x plus 7 that's still left over. And down below, we still have an 8. For this problem, we can't factor this at all. And we can't really reduce this in any way because there's no way to split off these r's using multiplication. So this is actually already simplified, and all we can do is, follow the advice of if it's not broke, don't fix it. To simplify this problem, let's start by factoring to see if we can find any common factors. So for the numerator, I need factors of 10 that add up to negative 7. So we got 1 and 10, 2 and 5. 2 and 5 would work. Negative 2 and negative 5. So we have x minus 2 and x minus 5. Down here, we've got factors of negative 20 that add up to negative 1. So there's 1 and 20, 2 and 10, 4 and 5 works if you have positive 4 and negative 5. So x plus 4 and x minus 5 in whatever order you want to write them. And then we can cancel out these x minus 5's, leaving us with x minus 2 in the numerator and x plus 4 in the denominator. To simplify this one, let's start by factoring and seeing what kind of common factors we have. So for the numerator, I can take out a common factor of 5. That leaves me with an x plus 3. Down below, we can take out a 15, leaving us with an x plus 3. Well, that looks familiar. So let's deal with the 5 and the 15 first. So I can reduce those. That gives me a 1 and a 3. And I don't have to write the invisible 1 there. Now these x plus 3's are exactly the same factors, so those completely cancel. Left in the numerator, since I've crossed off everything, there's still an invisible 1. Since that's all that's left, we're going to have to write it. So we put a 1 up there. And down below we still have a 3, and that's about it. For this problem, there isn't really any factoring to do. This is all just reducing. 6 and 24, that can be reduced. Reducing it by 6's, we can get a 1 in the numerator and a 4 in the denominator. And then r to the 6 and r squared, since those are the same base, we can also reduce those. Subtracting the exponents, we get an r to the 4th upstairs. So when all is said and done, we end up with r to the 4th on top, and down below we have a 4. To get anywhere on simplifying this problem, we're going to have to factor things out in the beginning. So in the numerator, I can actually take out a common factor of 5. That leaves me with x squared minus 16, and I can factor that a little bit more in a minute. But let's look at the denominator as well. Looks like I can take an 8 out of all those. So that leaves me with x squared minus 10x. And then, well, let's see here. 8 goes into 225 times. So 24 then into 192. So factoring in the numerator now, let's bring down that 5 so we don't lose it. And then this is a squared minus b squared, basically. So we can square root those and put something in a plus b, a minus b format. So x plus the square root of 16, 4, and x minus 4. Downstairs, let's not forget that 8. And then I need factors of 24 that add up to negative 10. We got 1 and 24, 2 and 12. None of this is working so far. 3 and 8's a little bit better. 4 and 6, though. 4 and 6, if they're both negative, that would add up to negative 10. So we have x minus 4 and x minus 6. And as luck would have it, these x minus 4's cancel out. So that leaves us with a 5 and an x plus 4 in the numerator, and 8 parentheses x minus 6 in the denominator.